Excuse me for a moment. Thank you. In my presentation, we're going to step back from the Great East Japan earthquake for a moment and describe a new initiative from the PTS intended to improve the calibration of the IMS network with regards to accurately locating seismic events. And as I will summarize, the successful outcome of this initiative will rely on significant collaboration between the PTS and its member states, and it should have benefits that extend far beyond the treaty verification regime. At the PTS, we view as one of our key missions engaging our members in the research and development activities that will keep us abreast of advances in technology. We are a relatively lean organization, and we rely on member states for substantial contributions, either as contributions in kind or as part of their participation in our workshops, technical meetings, and expert groups. We especially rely on contribution of expertise from the more technically advanced and engaged members. And the other half of this important mission is therefore, in turn, to disperse this expertise through capacity building efforts for the other members and to encourage their deeper involvement with our organization. As a recent example of contributed technology, the USA has released the Regional Seismic Travel Time, or RSTT software and modeling framework that has resulted from a multi-year research program carried out in the USA. A fundamental problem in seismology is the accurate location of seismic events, and the PTS requires an accurate location to constrain an area for an OSI, on-site inspection. The member states, in their day-to-day working, the working seismologists use seismic event locations to identify potential seismic hazards in order to mitigate seismic risk. Now, accurate locations depend upon detailed knowledge of the Earth's seismic wave velocity structure, and that, in general, varies in a very complicated way in all three dimensions. The RSTT, or Regional Seismic Travel Time System, provides a framework for managing those complicated three-dimensional structures necessary to accurately locate events using local observations, basically less than 100 kilometers, and regional, and integrating those with the regional observations less than 1,500 kilometers. These locating events at these accurate location of small events are important both for treaty monitoring and for seismic hazard studies. The RSTT improves the IDC's capability to provide more reliable event locations, since event detection is tightly dependent upon event locations and the detectability of the small events of interest. RSTT is also available for the member states to use in their applications, both for their treaty monitoring purposes and for their seismic risk mitigation purposes. However, this is not a magic bullet. As you might guess, there's a lot of work involved to bring this thing to fruition in the various areas of the world. We must first calibrate the velocity model using known sources of seismic energy. By known sources, this means that we need to collect well-located ground truth events with accurate locations and accurate travel time measurements associated with them. So far, the model has only been calibrated for North America and Eurasia. And in these regions, there have been large international collaborative efforts to collect ground truth events with the reliable travel time measurements. And again, this was instigated as part of an effort by the CTBT member states to improve event location. Now, this is an effort that will need repeating in the other regions where we would like to apply the method. So what is RSTT in brief? It's a simplified approximation to the Earth, and it is a under testing experience, our testing experience has shown that this is a good approximation that works well in many cases for the regional and local distances. The approximation was developed explicitly so that if we have the data, which are these seismic travel times associated with well-located events, then we can apply tomography techniques to extend the RSTT velocity model. This means that we can calculate new velocities for paths between our ground truth sources and stations where the event is observed, and by crossing path methods similar to a tomography method that you'd see in your doctor's office, we can derive a velocity model for the Earth. So therefore, to calibrate our models, we need to collect ground truth data and perform the tomography processing. This is an involved task that requires cooperation and collaboration among many seismological communities in their respective areas of interest. There are many local and regional networks that can be used to help constrain ground truth event locations and provide accurate travel time measurements, and we need to get these, we need to determine these, identify these networks so that we may be able to assemble a set of events with what we call ground truth level 5, or located within 5 kilometers accuracy, which would be about the minimum accuracy required for a ground truth event. Therefore, the challenge is to identify all of the regional network operators that acquire local and regional data, and then be able to get them to release their data for processing at the IDC. So the PTS is initiating a project to collect more data and to target in these target regions, which include Africa, South and Central America, and Australia and Southeast Asia. Note that there are two parts to this. One is the acquisition of ground truth events, and the other one is to perform the tomographic studies. We would like to point out that there is individual value in both, individual and interdependent value in both parts of the project. Ground truth data is valuable in its own right to help calibrate seismic measurements. The RSTT model, which is in advance for now, still remains an approximation limited by currently available computational resources. And as we improve the RSTT framework to be more accurate later on, we will certainly revisit the derivation of these models within the next 5 years to take advantage of new developments. But any newly introduced technique, I would like to point out, will still depend upon our collection of and basic ground truth data sets. So to help us with our project, we are actively recruiting participants, which includes those member states that can help us identify and coordinate regional and local networks in the areas of interest. And these member states are encouraged to contact us to see how we could collaborate in the future. Thank you.
Many thanks, Jeff.